Good evening to all. Now today we are going to discuss relation between KH, that is hydrolysis constant, and H, that is degree of hydrolysis for salt of weak acid and strong base. Now consider 1 mole of salt Ba of weak acid and strong base dissolved in V liter of water. So when salt Ba, that is salt of weak acid and strong base, is dissolved in V liter of water, then the following reaction is expected. So Ba is our salt, which is a salt of weak acid and strong base. When dissolved in V liter of water, it is expected to give BOH and HA, that is acid and base from which that salt is formed. Now we know very well that our acid in this case is weaker one and base is stronger. Thus ionic reaction for this reaction, this equilibrium, is given as B plus plus A minus, as salt is strong electrolyte always, plus H2O, which happens to be weak electrolyte. Now our base is stronger one, thus it can be given into ions, that is B plus plus OH minus, and acid is weaker, so remains same. Now the common B plus ions to the both side get cancelled, so A minus plus H2O gives OH minus plus HA. So it is the hydrolysis of salt, as A minus is one of the ions of salt reacting with water, producing basicity in the solution. Now we have taken 1 mole of salt Ba, so A minus represent the entire concentration of salt. Thus 1 mole, out of 1 mole of A minus, let H moles get hydrolyzed. So at equilibrium, H moles of OH minus and H moles of HA are present in the solution, as we are considering that out of 1 mole of salt Ba, that is A minus, which is the representing the salt, out of 1 mole of A minus, H moles get hydrolyzed. Thus solution contain H moles of OH minus and H moles of HA. Now unhydrolyzed moles will be 1 minus H. Now moles per liter at equilibrium, I am talking about the concentration, will be, thus concentration of A minus will be 1 minus H upon V, concentration of OH minus equals to H upon V, and concentration of HA is equal to H upon V, as all the ingredients are present in V liter of water. Now if at all this equilibrium, I mean if we apply law of mass action to this equilibrium, then we get the hydrolysis constant, that is KH. So KH is equal to concentration of OH minus into concentration of HA upon concentration of A minus, and practically concentration of water remains constant. Now if we substitute or put these values, I mean values of concentration of A minus, concentration of OH minus, and concentration of HA in this equation, then we get KH is equal to H by V into H by V upon 1 minus H by V. Now this can further be given as KH is equal to H square by V square upon 1 minus H upon V. So further this can be given as KH is equal to H square upon 1 minus H into V. We have taken 1 mole of salt and dissolved in V liter of water, thus 1 by V gives concentration of the solution. Thus this can be given as KH is equal to H square C upon 1 minus H, as 1 by V is equal to C, that is concentration of solution. Now we know that H is very small as compared to 1. So as H is very small as compared to 1, thus 1 minus H will be approximately equal to 1. Hence one can give KH is equal to H square C. Thus H is equal to under root of KH upon C. Hence one can say that degree of hydrolysis of salt of weak acid and strong base is inversely proportional to the square root of its concentration. Thank you very much.